going to work with rational exponents. We're going to work with changing something from an exponent to a root. So if you have it in exponential form, it looks like this. X to the 1 over n becomes the nth root of something. So an example would be, like, let's say it's 8 to the 1/3 power. So if I had 8 to the 1/3 power, that denominator becomes the root. So that would be the cube root of 8, which then we can evaluate that without a calculator. What's the cube root of 8? 2. Okay. So, right? So we can change something from an exponential form with a fraction into a root. So let's write a to the 1/5 in radical form. So it would be the 5th root of a. And then if it's the 8th root of c, that would be c to the 1/8. Okay. Now that's if the numerator is a 1. We just have a root. What if the numerator is not a 1? Yeah, so here, so if it has b to the x over y, so what happens is,
The x goes in under the
yeah, so this ends up being the power, and the bottom number is still the root.
Crazy how that works out.
Oops. Okay. Okay, so c to the -5 is under the cube root. So how would we rewrite this? So it's going to be c to what power? -5 over 3. That's it. Okay. So the power goes in the numerator, right? So whatever the top number is, right, that's the power. And the root is the bottom number. So what if it's 7/4 power? What's d gonna, what do we put on the outside?
4 root b to the 7th power.
Yeah, and you can put the 7 underneath, or you could do 4th root of d and then to the 7th power. Okay? Well, sometimes it's easier to do this one when we're simplifying. You'll see. Don't worry. Okay, so we want to evaluate these exponential expressions without a calculator. Okay, so 49 to the -1/2. First of all, what's the negative do to a power?
switches it around.
It makes it I.
Well, that would be if we had a negative under the square root. But if we just have a negative exponent,
Flips it.
it flips it. So it becomes,
One.
no, just the half. So if I have a negative power, I just rewrite that as 1 over 49 to the +1/2. Now I'm going to rewrite 49 to the 1/2 as the square root of 49.
You can't have a square root in the denominator.
Okay, but can we evaluate square root of 49?
Yes.
Yeah, 7.
7, so it's 1 over 7.
Which is 14.
So 49 to the -1/2 is the same as 1/7. That's a square root.
I was just saying, so why is it?
It's just a square root.
But they
You don't need the 2. Anything to the 1/2 power is just a square root.
Because I was gonna say that cancels out. If it's the square, it cancels out the square root of when they were just 49.
No. We're taking the square root of 49. We're not doing square root of 49 squared. It's just square root of 49. Okay.
I get it.
Next one. What do we have? We have the 5th root of 32. And I'm going to put the 2 on the outside because taking 32 and squaring it without a calculator and then doing the 5th root is too much work. So instead, What's the fifth root of 32?
2.
2. So then we have 2 to the second power,
Which is just
4.
which is 4. Okay. Because 2 to the 2 times 2 times 2, that's like, there are certain powers that we should probably memorize. So like the cube root of 8 is 1 that we should know. That's 2 squared. Okay. Okay. All right, 1/25th to the negative 3/2. So first thing I want to do is change that to a positive 3/2. So take the reciprocal, and that would be,
the opposite reciprocal.
so just not the opposite, because you don't have to change the sign. Just change 1/25 to 25 and make it a positive 3/2. Yeah, and now let's rewrite that as the square root of 25.
Square root of 25.
And then we want to cube that. Right, so the bottom number is the root. Sorry. So what's that? What's square root of 25? 5 to the third.
Cubed on the 25, yeah.
Right?
Oh, yes.
A lot easier than what we did last lesson. Okay. This is and this is only a 2-page lesson. So, okay, simplifying expressions with rational exponents. Okay, so first of all, you can't have any negative exponents in your answer. Good? Okay, you need to make sure that there's no exponents that are not positive integers in the denominator. So in other words, you can't have a fraction in the denominator, okay? What's a complex fraction? That's like a fraction within a fraction, okay? So we can't have that. And the index of any remaining radical is the least number possible. I'll explain that. That's kind of confusing in words. Okay, so all the rules of exponents still apply. So if I have y to the 1/7 times y to the 4/7, what can I do to the exponents?
Put them together.
Yeah, just add them, right? So we're going to take, what's 1/7 plus 4/7? 5/7. Okay. Do I have any negative exponents? No, I don't have any fractions in the denominator, right? So we're good. Okay, x, what's wrong? There's nothing else that we can do with this. Yeah, because all I can do is add the exponents here. Okay, I have x to the negative 2/3. So I could do 1 over x to the 2/3. Now, I can't have exponents in the denominator that are fractions. Okay, so we're going to multiply. So this actually does look a little bit like when we had radicals that we were simplifying. What would we have to combine with 2/3 to get an integer exponent?
1/3.
1/3. So why do I choose 1/3? Because I want to make sure whatever I multiply by, I get an integer exponent. So in this case, that will make it 3/3. So that would just be x to the first power. And it's okay to have a fraction in the numerator. So it's just like with square roots, right? I can have a square root in the top, I can't have one in the bottom. So same thing with the fractions, it's the exponent. All right, 6th root of 16 over cube root of 2.
Whoa.
What do you think?
Uh-oh. Right off the bat.
Multiply both by cube root of 2.
Can simplify.
We can simplify this.
By 2.
Okay, let's rewrite. What's 16?
4.
It's 2 to the 4th power. Could we make this a 1/6 power on the outside?
Whoa, 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 whoa,
Whoa.
whoa. Wait, what? I'm not. How the heck did you get that?
I don't like that.
You don't like that?
No,
Not like that.
Well, We just practiced with changing from roots to powers. So if it's a 6 root, that would be a 1/6 power.
Oh, so true.
Okay, look at the denominator. How can I rewrite that with a power? 2 to the,
1/3.
okay. Can I simplify the numerator? What can we do when you have a power raised to a power? Do you add or multiply the exponents? Multiply. So what happens when you multiply 4 times 1/6, which is 2/3? Okay, so I have 2 to the 2/3 over 2 to the 1/3. What can I do now that I have the same base? What do we do with the powers?
Cancel them out.
Cancel them out by?
Divided by 3, 2,
Multiplying 2 to the third.
2 to the power of 1/3.
I mean, we could do that.
Just divide them so they subtract each other.
Yeah, remember when we had something like this? X to the 5th over x squared? What do you do with the powers? You just subtract them, right? So can't we do the same thing here?
Yeah.
Okay, so what's 2/3 minus 1/3?
1/3.
1/3.
Wow. That's simple enough.
Okay. Okay, I'm going to do something similar in the next one. I see a 6 root, so I'm going to put a 1/6.
Wait, can I just say something?
Sure.
Still don't understand how we got to
Yeah.
power
Yeah,
4
same.
Yeah, me either.
16.
Oh, 16 is 2 to the 4th power.
How do you
Like if this was an 8, I would write 2 to the 3rd power. If this was a 4, I would write 2 to the 2nd power.
Well, 1/6
Can you write
just flip
4 to
it.
the second power?
You could, but then you wouldn't be able to subtract the exponents if you have a different base. So, yeah, I'm trying to make them have the same base. Like 2 to a power.
Oh, okay.
And
I
then,
get that.
and then what's the name? You just flip the 6.
Wait.
Yeah. So I rewrote this as a 1/6 power.
But how do we know if, like, not to do 4 to the second, just 4 squared?
If the bottom.
Because the bottom has a 2. If the bottom had a 4, then I would probably keep it.
For B, shouldn't we have done 2/3 instead of 1/3 for that?
Which one?
For multiplying the denominator. You wrote 1/3, I think it should be 2/3.
No, this was 2/3. So when we multiply variables, we add the exponents.
Oh, so you want to make it 3/3?
I want to make it 3/3.
Got it.
Okay.
We added them to make it 3/3, which is
Okay, now 4, I'm going to write that as 2 squared and x to the 4th.
X to the what?
4.
So can I multiply the exponents? That will be 2 to the, what's 2 times 1/6 is 2/6. So that would be 1/3. Right? 2 times 1/6 is 2/6. That makes it 1/3. How about here? 4 times 1/6? 2/3. Okay, now you can leave it like this. Or, what do we notice about both denominators?
3.
They're both 3. So you could write that as the cube root of 2x squared.
You could.
I'm fine with either one. This is kind of like going an extra step.
Oh, yeah. I don't like doing extra.
You don't like extra. Okay, so leave it the first way.
You could base it.
Okay. All right, what do you think in the next one?
Oh, this one looks a little.
Okay, what is a 1/2 power? What root? It's a square root. So if it's easier for you to write it as square root of y plus 1 over square root of y minus 1. And then we have to multiply by what's called the conjugate. Remember, to get rid of the square root in the denominator? Yes. So what would we have to multiply by?
Root y minus 1.
No. We want it to be the opposite of the bottom one.
Oh.
So root y plus 1 Okay,
Hold on.
so we're gonna FOIL the top and we'll FOIL the bottom. So let's see, square root of y times square root of y will just be y. Then we do the outside, so that will be plus root y. Inside will be another plus root y. And then 1 times 1 is just 1. Okay, in the denominator, root y times root y is y. What happens when we do the outside and the inside? They're just going to cancel out, right? Because we'll have a plus root y and a minus root y. And then what's, so these are going to cancel. Okay, so what do we get for the final answer? In the top,
Y plus
2 root y plus 1 all over.
Y minus 1.
Yeah. So did we get rid of the root on the bottom?
Yes.
Yes. Okay, last one, and that gives us lots of time to do some homework. Okay, my goal is, or actually, hold on, before I do that. My goal is to, we don't want to have any fractions in the denominator, but what can we do first? Not cross multiply, but what, remember what I said here? If I have x to the 5th over x squared, what do I do with the exponents? Subtract them. So let me just rearrange these. Let's make it b to the 3rd over b to the 1/3 and c over c to the 1/2. Yeah, because you're just, it's right, it doesn't matter if you have 2 times 3 or 3 times 2, it's the same thing. So I can put the b's together and then the c's together. All right, so what do we want to do? We want to take 3 minus, so 3 minus 1/3.
To the two-thirds power.
So the 2 and 2/3, which is, well, here, make this 9 over 3, so 8/3. And what do we get for c?
C to the 1/2 power.
To the 1/2. Easy enough? That's it?
Oh.